45-day LeetCode coding challenge, and today we are going to solve our next problem statement: delete the middle node of a linked list. Let's start. You are given the head of a linked list. Delete the middle node and return the head of the modified linked list. The middle node of a linked list of size n is n by 2. Node from the start using the zero-based indexing, where x denotes the largest integer less than or equal to a x. For n equal to 1, 2, 3, 4, 5, the middle node are 0, 1, 1, 2, 2 respectively. So we have given a linked list and we need to remove the middle node from it. 0. So if there are 7 nodes, so in this node there are 7 nodes, but our indexing starts from 0. So now our value of n will be 6. Now, and we can do 6 by 2, so our middle node will be 3. So you can count it 0, 1, 2, 3. So this 7 element node we need to remove. For second, the number of node is 4, but our counting starts from 0. So n is equal to 0, 1, 2, 3, 3, and we can do 3 by 2. So it comes at 1.5, but when we convert it, it will come as 2. So 0, 1, 2. Similarly for this, this one, 1 by 2, it comes at 0.5, and when you do the floor function, it will come as 1. So that's why this one we need to remove. So for first one, if we remove the 7, the output will be removing this 7, 1, 3, 4, 1, 2, 6. Similarly, for second, remove the 3, and the output is 1, 2, 4. For this one, remove the 1, and the output is 2. So the problem statement is simpler. Let's try to solve this problem statement. One way to solve this problem statement is to iterate over the linked list and count the number of elements and count the number of nodes. So first you need to write the for loop to iterate over your whole linked list and then count the number of nodes. Then you can again iterate to n by 2 and remove the middle element. So this is the one approach, but there is another approach also where we can find the middle element easily instead of counting the number of nodes, then again iterating and finding the n by 2 node. What we can do, we can define 2 pointers. Suppose we have a linked list like this: 1, then 2, then 3, then 4, and 5, and 6. This is our linked list. We can define 2 pointers. One is our middle pointer, and second can our front pointer. So our middle pointer goes 1 step at a time, but our front pointer go 2 steps at a time. So middle pointer goes 1 step front, but go 1 step forward, and our front pointer move 2 steps forward. Now let's try to do it in this linked list. So middle is initialized and front is initialized by value 0. Then our middle moved 1 step forward. So our middle now pointing to 0. It starts from 0 and now it is pointing to 1 position. Front is moved 2 steps forward. So now it is pointing to the second position. So middle is at the 2 position, but our front is to the 3 position. Then again we do the same process. Middle move forward by 1 step and front move forward by 2 steps. 2 plus 2, 4. So now our middle is at 3 and our front reached to our 4th position. So 0, 1, 2, 3, 4. So it reached to the 5th position. Now again we do the process, and middle is reached to the 3rd position and front moved by the 2 position. The 4 plus 2, 6 position. So 0, 1, 2, 3, 4, 5. So now our front has reached to the null value of the node and our middle value is reached to the 4th position. So as soon as our front reached complete the linked list iteration, our middle will point to the middle element of the linked list. So right now our middle is pointing to the 3rd position, which is correct. 6 by 2 is 3, and our indexing starts from the 0 position, so our middle element is 4, which is correct. So by this approach, we can solve this problem statement. Let's do the coding part now. We have our middle node. We are initializing it with the head pointer. Another node, the front node, initializing with the head pointer. And to keep track of the previous node that we will use at the end to remove the middle element, we are initializing it with the null value. Now we iterate till front is not equal to null, front is not reached to the end of the linked list, and front dot next is also not pointing to the null. We iterate over the while loop. We move our middle element one step at a time. So middle equal to middle dot next, and we move our front pointer two step at a time to front dot next dot next. Now we also need to keep track of the previous node of the middle. So we initialize it with the middle element, then move our middle element one step at a time and move our front element two step at a time. And we comes out of the loop as soon as our front pointer complete the linked list. So our expectation is as soon as the while loop is completed, we will get our middle node. So now we have our middle node. We can remove our middle node. We have the track of the previous node of the middle node. So what we can do, previous dot next equal to middle dot next. To remove the 7 from it, we have the previous node 4, and what we can do, 4 dot next equal to 7 dot next. So that this 7 dot next will get removed, and this 4 will directly point to the 1. So we are adding this 9. Now return your head pointer. Also, one more thing, if there is only one element in the node, this while loop might get failed, or maybe it will not work. So if our while loop will not execute and there is only one element, and if our previous value is null, if there is only one element in the linked list, we need to remove that particular element. So we are returning null. So this is the one edge case when we have only one element in the linked list. So now let's run the test case. Our test case is working. Now let's submit the solution. Yeah, so our solution is also working. And thanks for joining the session. Let's meet tomorrow.